We're going to talk about our sweet firewall project. So get in tune.
All right.
Take it away.
Thanks, Michelle.
Yep.
All right, so before I get into the presentation, just a quick show of hands. How many of you have ever tried taking care of a house plant? Okay, so most of you, that's good. Okay, how many of you killed that house plant? All right, yeah. Well, what if I told you that by letting that house plant die, that you might have been endangering your own health? That's kind of what we do a little bit, is look at the relationship between indoor air quality, the filtration that that house plant could provide, or in our case, the biowall, and how that impacts human health as well as energy efficiency. So the title of my presentation is Biowall, Planting a Healthy Home. So just a little bit about the team. We're part of a interdisciplinary design competition. I'm leading a team of interdisciplinary undergraduate students. You can read what we have up there. Michelle was actually responsible for a number of the graphics during this presentation and the formatting, so thanks goes out to her. And you can see some of the many departments that we have, everything from biochemistry, ag and bioengineering, horticulture, interior design. We've tried to get as many different people across the board involved in this idea of a biowall, which I'll go into a little bit more later. So what am I going to talk about today? I kind of have a pretty standard presentation format as far as this goes, but hopefully the presentation itself isn't as regular as you see with most of these papers. Actually, we'll wait till the end for that video, but I've got a video that might help summarize some of what we're talking about today. And I'll jump right into the introduction. So, just some fast facts for you. Americans spend about 90% of their time indoors, where indoor air quality is 2 to 5 times more polluted than outside air. This is caused by what we call VOCs, volatile organic compounds, which are off-gassed by all sorts of man-made products. So, if there's some sort of sealant or adhesive, or anything along those lines, it's constantly off-gassing these chemicals into the air. And what we found is that these chemicals can be pretty hazardous to your health. There's a list of different things on there, and even things beyond that. It turns out that in the atmosphere, if you look at this image we have up here, about 10% of the VOCs in the atmosphere are man-made, and about 90% are just naturally occurring VOCs. So what I'm trying to get at there is that not all VOCs are necessarily bad. Some of them are naturally occurring through ecological reasons of plants, or a sense of smell, or other sorts of chemicals that might be created in the natural environment. But man-made ones, as I said before, paint is a really common one, cleaners, things along those lines. So why is this important? Well, if we look at this from, a lot of this is based around, so we're part of a sustainable design competition, and we're looking at the 3 pillars of sustainability: people, prosperity, and planet. So when we're looking at people and public health, we want to look at kind of the social justice side of things too. How does indoor air quality affect people? And what we found is that both the old and the young are the most vulnerable to the problems in indoor air quality. Looking at the elderly, there was a study done in France of, I think, 40 different dwellings. And they found that the elderly are more often exposed to these VOCs due to some of their lifestyle habits. And that's shown in this image I have up here. Everything from whether there's fitted carpets, whether their dwelling needs some sort of renovation, they spend more time in the kitchen, different odors, and cleaning products. And I don't know, I've got a bit of a weird sense of humor, so I thought that was a little ironic that, you know, people who are trying to make their area more clean through cleaning products and improve their health that way by avoiding germs are actually hurting themselves because they're creating chemicals from these cleaning products and breathing those in, which can be hazardous to health. The other thing is, let's see, with children, there was a study done that found that many of these VOCs can be neurotoxins, so they have damaging effects on the brain and can also cause behavioral disorders in children. So what's the typical solution to this? Well, in the built environment, and this is kind of starting to move towards the planet side of sustainability and energy efficiency, the typical solution is just to ventilate the space. So if we've got a room like this, we're constantly off-gassing all these VOCs, and the solution is to just bring in a bunch of outside air and then exhaust it right away. Well, what's the problem with that? Well, that outside air, we got to take the outside air and we got to heat it up. On a day like today, maybe not so much, but you know, if it's the middle of winter and we need to heat it up, that's going to take a lot of energy. Same thing with summer, we got to cool it down so that it can be at room temperature when we're ventilating the space. So it's energy intensive to go through this ventilation process. There's some other solutions, such as limiting the exposure of VOCs to begin with, and that's kind of why I showed that paint can up here. But that's kind of limited. You're limited by what products are available on the market and what you can find. There's also other gaseous air cleaners out there that can remove VOCs from the air, but a lot of those will saturate over time. So what we're proposing, and I'll get into this in just a minute, is something that can clean the air and it can do it sustainably, to keep doing it over and over again without needing replacement all the time. And more fast facts for you, $125 billion were spent annually in the United States on lost productivity due to poor indoor air quality. And then the last point I wanted to make is that when we're bringing in ventilation air, there's also energy efficient solutions. So there's this thing called an energy recovery ventilator that's commonly used, and that's kind of, in a way, a competing technology to what we're proposing with the biowall. Looking at the planet side just a little bit more, many of you know a lot about this already, so I'm not going to spend too much talking about sustainability, climate change, natural resource consumption, all those sorts of things. But if you look at energy efficiency, as our society tries to become more sustainable, we're going to try to build more energy efficient houses. The problem with energy efficient houses is, as we try to seal up those energy efficient houses and reduce the amount of air that leaks in, causing drafts and things like that, we also reduce the amount of natural ventilation. So then we go to a mechanical ventilation system, which, as I said before, is very energy intensive. And currently about 20% of the energy use in the United States goes into the residential sector. And then, as I said before, energy efficiency, natural resource consumption, they all have links to climate change. So what's going on internationally right now? If you look at Beijing, right now they have record-setting levels of air pollution in the city. It's actually so high at this point that it doesn't fit to a standard metric. So our typical ways of measuring air pollution, it's off that scale, and that's the level it's currently at. As far as India is concerned, they have high pollution as well, but there was an entrepreneur in India who decided he wanted to try something a little different. He decided that he'd put a bunch of potted plants in what he called clean air stations, I think is what he referred to them as, and he would put these throughout his building. And what they found actually was that in his building there were dramatic health increases because they had all these plants filtering the air for their building. I think if you look at that graph I have on the bottom left-hand corner, they actually saw an increase in lung performance. So people were breathing easier and they could do more because they spent time in this building and not in the ambient air in India. So what's our solution? So getting to what I'm doing and our solution for this project is, it's a form of phytoremediation, which is kind of a $2 word or whatever, but it's basically phyto, meaning plant, and remediation, solving problems. So what we're trying to do is we're trying to solve a problem using plants. And the idea is to take a living filter filled with plants and incorporate it into the heating and cooling system of an energy efficient residence. And by doing this, we can improve the indoor air quality, and we can also reduce the energy consumption as a result of that. And we call it the biowall. So you've got a basic image of what's going on with that. You start with unhealthy air, you run it through the biowall, which can filter the air, and the way that is possible is through microorganisms in the plant roots, and then it leads to a happier, healthier environment. So just to give you a brief overview of the history behind botanical air filtration, as it's called, It started in NASA research. So NASA was looking at how do we go into deep space and how do we, sustain that kind of environment over a longer term. And they began looking at plants to, create this symbiotic relationship with the astronauts and be able to exchange air between the two. So it started with a man named Bill Wolverton who did initial studies in how to reduce VOCs. From there, a man named Alan Darlington, Dr. Darlington, in 2000 he started looking at the ability of plants to filter the air, but also what impact that had on psychological effects as well as physical health effects. And then more recently, looking into 2011, the first study was conducted that looked at energy efficiency as a result of that improvement. And that was done by researchers at Syracuse University in New York. And so that's kind of where we come into place is in 2011. Some of you might have heard, just by a show of hands, how many of you have heard of the solar decathlon competition? Or maybe saw the Purdue house, the in-home? Yeah, okay. Well, if you saw the in-home, you saw the beginnings of the bio wall. And that was the first time that we had a chance to kind of move into this field.